Hey guys, today we are going to continue with rational functions, but we're specifically going to focus on slant asymptotes. This top part is kind of just like a little review of what we've been doing. So let's take a look at this first. It says that not all rational functions have vertical asymptotes, and we saw that in some notes from last week, right? So first we're going to start off by just simplify each rational function algebraically, graph the original and the simplified version in the same window, and make a generalization. So let's look at this first example right here. Notice that the numerator has a GCF of x, so I can take out an x, I'm left with x plus 3 all over x, okay? Because there's an x in the numerator and denominator, they divide each other out. So then I am left with f of x equals x plus 3. Now the directions tell us to graph the original function, this guy, and the simplified version in the same window on our calculator. So let's go ahead and pull out our graphing calculator. And we've got y equals screen. Okay, alpha, y equals, let's type in this guy. X squared plus 3x all over x. And then my simplified equation was x plus 3. Let's go ahead and graph that. Okay, notice that this red line is going right over top of that blue line, that this ends up being the same line. Okay, so these are the same graph. And just a quick little review, what happens when we undo those x terms? That means that there is a what? Good, there's a hole. There's a hole then at x equals 0, okay? Because remember, if we set that x equal to 0, we just say that x equals 0. So that's where we have a hole in our graph, okay? All right, let's do g of x. Okay, it looks like we have a difference of squares happening in the numerator. So that's x plus 2, x minus 2, all over x minus 2. Okay, we have x minus 2 in both the numerator and denominator. So g of x now is just x plus 2. Okay, and because we were able to cancel out those x minus 2's, that means we have a hole at x equals positive 2, because when I set x minus 2 equal to 0, I get x equals 2. So let's go ahead and graph this real quick though. So let's see, this was x squared minus 4 all over x minus 2. And then I have x plus 2. Is that right? Yep, okay. And again, we have the same graph. Okay, let's do one more. This is already factored out for us, which is kind of nice. Notice that there's an x plus 3 in both the numerator and denominator. So I'm left with that h of x equals x plus 2 all over x minus 4. Okay, and there is a hole at x equals negative 3, because when I set x plus 3 equal to 0, I get x equals negative 3. Let's go ahead and graph that guy. I'm just going to clear that whole thing out. So let's see here. We have x plus 2 times x plus 3 all over x plus 3 times x minus 4. Oops. Let's do alpha equals, okay, x plus 2 all over x minus 4. Notice that, okay, we can see the hyperbola going on here. And then notice that that red line is going right over top of that blue line. So this ends up being the same graph as well. Okay, so basically just a generalization we just want to make here is that no matter if we're looking at the original or the simplified version graph, it's no matter what we type into the calculator, it's the same graph. Okay, so you can always check your answers of your rational function graphs with what you had, either the original function or you can use your simplified function. Okay, all right, discontinuities. are those x values for which a rational function is undefined. We've already talked about that. That's like a hole or a vertical asymptote, and so forth. A hole in the graph occurs when the same factor is in the numerator and denominator and must be drawn in by hand. Your calculator may or may not show the hole on the curve. Honestly, I've never seen a calculator show the hole, so I would just make sure you're recognizing whenever you undo factors that there is a hole, and you're just going to have to know that on your own, okay? And to find the y value for where that occurs, remember you just plug that back into the equation to solve for y. Okay, so then you get a coordinate point. All right, so that was a little review. Now on to something new, slant asymptotes. Whoopsies. Okay, slant asymptotes occur when the degree of the numerator is exactly 1 degree less than the degree, or I'm sorry, 1 degree more than the degree of the denominator. Whoopsies. 1 degree greater. Whoa, sorry. Is exactly 1 greater than the degree of the denominator. Totally read that wrong. My apologies. Okay, so for an example, it's like if I have x to the 4th over x to the 3rd, like some long polynomial, then I have a slant asymptote. If I have x squared over x, that's x to the 1st, so the degree of the numerator is exactly 1 degree greater than the denominator, so I'm good. Now, if I have x squared over x to the 3rd, I will not have a slant asymptote because the denominator is 1 degree greater than the numerator, so that would not be a good example. Okay, so those are examples right there. Alrighty. So looking down here, it says find the equation of the slant asymptote. So how we're going to do that is you're actually going to use long division to help you find that equation, okay? So the equation that we get from the long division is going to be the equation of your slant asymptote. So just quick little review over long division. Remember the denominator is what you put on the outside. And then the numerator is what goes on the inside. Okay? Now remember you have to figure out what times x gives me x squared. Well, x times x is x squared. Then you're going to take this term and distribute it to both of these outside terms. So I get x squared plus 3x. Oh, and I did forget to say, if you're missing a term right here, kind of like when we did the synthetic division, I would plug in a 0. So this would be like 0x plus 4 because we don't have that x to the first term. Because notice how these the like terms like line up, and that's kind of what you want to happen. So I suggest doing that. All right, so then we're going to subtract those. So let me get out a pencil here. So I'm going to subtract, that becomes a negative, and this also becomes a negative because you're distributing the negative to everything in here, okay? So the x squareds are gone. 0x minus 3x is negative 3x, and then you bring down the 4. Hopefully this is starting to come back to you with long division. Okay, now what times x will give me negative 3x? Negative 3. So I get x times negative 3 is negative 3x, and negative 3 times 3 is negative 9. Okay, and again, we're subtracting all of these terms here, okay? Think of it like this. When I distribute that negative, this becomes a positive, and this becomes a positive as well. So these are gone, and I'm left with 4 plus 9 is 13. Okay, so my equation is what I get up here. Okay, that's my answer. Y equals x minus, whoops, let's draw the plus sign. Okay, y equals x minus 3. That is your equation. Now, remember that this is called the remainder. You don't need it, okay? So you don't need to do anything with this. You can think about just like disregarding that, okay? So we're just going to disregard that, okay? Alrighty, and then that's the equation of your slant asymptote. And think about it, vertical asymptotes are up and down, horizontal are left and right. A slant would be like a diagonal, okay? So, and that kind of makes sense. That's just a linear line. So, and those look diagonal. Okay, number 5. Let's see here. So x plus 2. Oh, I do have a slant asymptote because look, the degree of the numerator is 1 greater than the degree of the denominator. So that's how you know that you need to look for a slant asymptote. X squared plus 4x plus 5. I'm not missing any terms, so that makes that easy. X times x gives me x squared. X times x, x squared. 2 times x is 2x. Remember, you're going to subtract those terms. Oopsies. So that becomes negative. That becomes a negative. 4 minus 2 is 2x. Bring down the 5. Okay. And then let's see. 2 times x will give me 2x. So I'm going to put a positive 2 up here. So plus 2. So then I get 2x. 2 times 2 is 4. And when I go to subtract those terms, that becomes negative. And this becomes negative. So I'm left with a 1. 5 minus 4 is 1. Now again, I don't need that remainder, so I can disregard it. Okay, so my equation is y equals x plus 2. And you just keep going until you've used all these terms. Like, you just keep bringing down the next term and the next term and the next term. Okay? Alrighty, so we're good there. Alright, that's how you find a slant asymptote. Alright, let's do an example down here. It says find the x and y-intercepts, all the asymptotes, identify any holes, and draw the graph of each. So, basically kind of like what we did last week, but now we're just going to throw in the slant asymptote as well. So if I simplify this, this becomes x plus 3 times x minus 3 because that's a difference of squares. X plus 3's go away, so I'm left with x minus 3. That's my equation. Notice this is a linear function now, y equals x minus 3. That's linear, so I'm going to have a linear line over here. All right, and you guys can also graph this on your calculator to double check your answer. All right, so x-intercepts, let's start there. You can use either or to find your x-intercepts, okay? I'm going to use this function because it's just a lot easier to deal with. All right, so x minus 3 equals 0. X-intercepts are when y equals 0. So x equals 3. So 1, 2, 3. Y-intercept. Oh, I guess you can write that as a coordinate point if you want to be more correct. Okay, y-intercept is when x is 0. So I get y equals 0 minus 3. So y is negative 3. 1, 2, 3. Okay. Asymptotes. All right. Now you have vertical asymptotes, horizontal asymptotes, and slant asymptotes. I'm going to say SA for slant asymptotes, okay? So now you have 3 different asymptotes you need to be looking out for. So for a vertical asymptote, we actually aren't going to have one because the denominator is gone now. So none. And also think about it, this is actually a linear function, and those do not have vertical asymptotes. Horizontal asymptote, again, we have a linear function. There is none, okay? And remember, if the degree of the numerator is greater than the degree of the denominator, we do not have a horizontal asymptote. Okay, let's look for slant. Slant asymptotes occur when the degree of the numerator is exactly 1 degree greater than the degree of the denominator, which that is true. Sorry. That is true, but notice that when we simplify this, again, this is a linear function, so we aren't going to have a slant asymptote. So you guys just have to be kind of careful with that in those linear lines. Okay? Alrighty, holes. We do have a hole because we canceled out factors. We canceled out x plus 3. So there's a hole at x equals negative 3 when I set that equal to 0. And to get that coordinate point, I need to find the y value. I'm just going to plug negative 3 in right here. Negative 3 minus 3 is negative 6. Okay. That's 3, 4, 5, 6. So there's a hole. Okay, and if you graph this on your calculator, you're just going to see a straight line. There won't be a hole on that point. So just make sure you're identifying that. Sorry, I'm trying to find my a little straight edge right here. Okay, and that's your line. That's it. Okay? All right, on the back side, we've got 2 examples left. Okay, find the x and y intercepts, all the asymptotes, identify the holes, and graph the function. That's what we're doing on number 7 and 8. So, let's start off by doing the x-intercepts. Okay, first off, I need to see, though, can I simplify this function any further? Let's see if we can factor that out. X minus 2 is in the denominator. Okay, so 2x times x will give me 2x squared. Factors of 1 are only 1 and 1. These either both need to be negative or both positive. It looks like they both need to be negative. Oh, whoa, why did I write a 2 right there? Silly me. Okay, so 2x squared minus 2x minus x, that will give me the negative 3x. Negative 1 times negative 1 is positive 1. All right, so x-intercepts. Let's see here. That's just going to be when the numerator equals 0. So I'm just going to take those factors and set them equal to 0. I think that'll be a lot quicker and easier to find those x values. So we get 1/2 and 1. Okay. So let's go ahead and plot those. 1/2 and 1. Okay, y-intercepts. That is when we plug 0 in for x. Sorry, link in there for a second. So that's 0, 0, 1. 0 minus 2 is negative 2. So that is just 0 at negative 1/2. Okay? All right, asymptotes. Horizontal. Let's see. The numerator degree is greater than the denominator, so I do not have one. None. Vertical asymptote. We do have a denominator, x minus 2. Set that equal to 0, so x equals 2. So that's 2. Let's draw in that horizontal, or I'm sorry, the vertical asymptote. Okay. Now we have slant asymptotes that we need to look for, which we do have a slant asymptote because the degree of the numerator is exactly 1 degree greater than the denominator. So in order to find that, remember I have to do my long division. So I have x minus 2 all over 2x squared minus 3x plus 1. Okay, I'm going to have to multiply this x by 2x to get 2x squared. So 2x squared, that becomes minus 4x. Okay, when I subtract this becomes negative, this becomes positive. That's gone, so I'm left with x. Bring down the 1. All right, I'm going to need to multiply this just by a 1 to get x. So 1 times x is x. 1 times negative 2 is negative 2. This becomes negative, this becomes positive. So I get 3. Give me 1 second, guys. Alrighty, hold on 1 second, guys, sorry. Can you shut my door, please? Alright, from here, sorry about that. So we have a remainder, alright, so our slant asymptote equation is 2x plus 1 because there's nothing else to bring down, so that's how I know I'm done. Okay, so, whoopsies. Let's see here. Okay, slant asymptote. I'm just going to graph this like I would a linear line. My y-intercept is 1, and I have a slope of up 2 over 1. 2 over 1, up 2 over 1. And I also can go down 2 to the left 1. All right. Let me actually get out my ruler here. I'll make it a little better. I'm going to make this line dotted as well. Okay, from here, I'm going to start to connect my points. So you can graph this in your calculator to get a better idea of what this is going to look like. But if I start to connect my points, it's going to look something like this. Okay, and then I'm also going to have something up here. You guys can graph that in your calculator to double check it. Okay, and that's all I would expect you to do. All right. Okay, we've got one more left. Oh, and I did forget to mention we do have no holes because we did not cancel out any factors. Okay, all right, now we're officially done with that problem. Alrighty, last one. Okay, let's simplify this guy. I have x plus 2 in both the numerator and denominator. Those can go away. So I'm left with x minus 3 all over x minus 4. Okay. Then I need to look for my x-intercepts. And we'll have like blanks for you guys to fill in all of these like on a test. We won't make you memorize everything you have to write down. So we'll make sure that you guys have an area to write this all down. So X-intercepts, really I just need to find when what makes this numerator equal 0. So let's see. X equals 3. So at 3, 0, I have an X-intercept. 1, 2, 3. My Y-intercept, let's see, that's when X is 0. I'm just going to go ahead and plug it into the simplified version because it will be less algebra. So I get -3 over -4, which is just 3/4. So at 0, 3/4. Okay. And then let's see. Okay, I have a hole at X equals -2. I got to go find that Y value though, right? I have a hole because those factors undo each other. So let me plug in the -2 right there. I get -2 minus 3 all over -2 minus 4, which is -5 over -6. So I have a hole at -2, 5/6. Okay, that's a little funky number. So let's see here, -2, and then 5/6. That's going to be like right before we hit that 1. Okay, something like that. Alrighty, now let's find all the asymptotes. Horizontal asymptote. These are going to have the same degree because this is x squared and x squared, but notice when I FOIL that out, it will just be like a 1x squared over a 1x squared. So I just have when I divide 1 by 1, I just get 1. So that's where my horizontal asymptote is. So I'm going to use my ruler to make a nice straight line here. Okay. And then vertical asymptote. Set the denominator equal to 0. I'm really just going to focus on this guy because I already know the whole is taken care of from the 2. So x minus 4 equals 0. So x equals 4. 1, 2, 3, 4. Okay. And then slant asymptote. Because I have the same degree in both the numerator and denominator, I do not have a slant asymptote, so I don't even need to worry about that. Okay? Alrighty. Graph this in the calculator. You guys will see that this just kind of curves down like this guy. Okay? And then you're going to have something up here that looks like this. Alright, so I just want this I want to be accurate. This can just be a rough sketch right here. Okay? Alrighty, I know that was a lot, but everything's starting to come together. Tomorrow you guys are going to do some more practice on this stuff, answering all these questions, finding x, y intercepts, holes, and all the 3 asymptotes. Okay? Good job today.